One of you asked for a shear analysis of pin structures in Abaqus, and today I'm going to show you exactly how to do it. Let's dive in and get this analysis started. Create part, we name it plate, 3D deformable solid extrusion 200. I create a rectangle like this. This guy meant to be 30 and this guy must be 100. Also, we want to create the hole here. This should be 10, the radius should be 10. Scroll button, the depth must be 10. We have the plate here. Now we want to create lines, partition face sketch. I select this face, done, vertical right, and we should create a line, and this should be 40. Done. And we want to sweep this along the edge, so left click, hold, and partition cell extrude/sweep. I select this one, scroll button, sweep along edge, select this edge and create the partition. It's good. Now it's time to create the pin and everything looks good. This should be 10 again and 20. Okay, now we have pen and plate. We can go to the property. We name it steel, general density 7.8 E-9, mechanical elasticity elastic 210,000, 0.33, and from mechanical plasticity and plastic, and copy paste these values, Control C, Control V. From mechanical ductile damage, we copy and paste these values. So from the sub options, damage evolution, we put the value of 0.4 here and OK. Now we create the section plate. It's from steel. Uncheck this one in order not to have too many sets and assign the section. Okay, now it's time to go to assembly, create instances. First create the plate here and translate it, scroll button to 0, 0, 0. Now I create another plate, but this time I want to rotate the instance. Select scroll button, this one and this one, 180, enter. Now it's translated. Click on OK. Now we can translate this one, scroll button, this one must go here. And now it's time to create the pen. Click on OK, translate this pen, scroll button, this guy can go here, and scroll button again. The assembly section is done. Now it's time to go to step, create step. Step 1, dynamic explicit, time 1, Elysium on, and use scaling here, create, scale 1E-4, uncheck this one, OK, OK, and from field output manager, edit, we should go here, status should be turned on in order to see the fracture, and the step is done. Now it's time to go to interaction. First I need to create interaction properties, plate dash plate, contact, mechanical tangential behavior, frictionless, and I want to create another interaction property for plate dash pin. Should be mechanical tangential behavior, and we want to have friction with a friction coefficient of 0.1, and normal behavior should be hard contact. So it's time to create the surfaces that we are going to apply the contacts on. and there's one contact between these two plates, and there's one contact between plate 1 and pin, and plate 2 and pin. Okay, so from tools, surface manager, we want to create the surfaces, create display group, put it on cell, edit selection, select this one, hold shift, select this one and hold shift, select this one, done, and remove them. You select this surface, it can be plate 1 and done, and create the second one, plate 2. We replace everything, and from create display group, edit selection, this one, this one, and this one should be selected, done, remove, rotate, select this one, done. This is the plate 2. You can create another surface inside plate 2, done. And also we should do it once more, this one, remove, inside plate 1, and there should be one which is pen, and replace everything, display group, this one, done, replace just this surface, that's true, inside plate 2, inside plate 1, and plate 2. Okay, let's create the interactions. From here, create, step initial, surface to surface, continue, and from here surfaces, plate 2, we can highlight this one, continue, surface, plate 1, continue. Now this is the plate to plate, and plate to plate, it's better to rename that plate to plate. Now we want to create another one, plate 1 pen, so we select the surface, pen, continue, surface, inside plate 1. It should be plate pen, and we create plate 2 pen, and this should be pen, continue, surface, inside plate 2, plate pen, continue. Now we have 3 contacts. Okay, we want to create another interaction, so let's first create a reference point here, and here from create constraint we create one rigid body. The point should be this reference point, and the body element should be this one. Okay, now it's done. Click on OK. Now it's time to go to the load boundary condition, create boundary condition 1 initial, this one. We want to rotate and select this one, done. It should be in cast, and we want to create another one here, displacement rotation, RP1, done. Select everything, create another one here, done. Select everything, but this one should be 5, and we should create an amplitude 0, 0, 0.1, 0.1, and it goes to 1 to 1. And here we select this amplitude, and continue. Okay, the load is done. It's time to go and create the mesh part. So this one cannot be meshed structured, but there's a solution for that. So here, left click and hold partition cell, define cutting plane. And here we click on done, 3 points. This should be this one, and this one. Create partition, and we do the same for this one. Scroll button, 3 points, this one, and this one. And we do that for this. Done, 3 points, maybe this one, and this one. Now we can create structured mesh. Now it's time to see the edges. We hold shift and select this one, and hold control and deselect that one. Done. It should be 8. Now we have 8 elements on each quarter of the circle. Also, we want to see the part. It should be 3. Mesh. And as you see, this one also cannot be meshed structured, and we should do define cutting plane for this one, 3 points. So this one, and also we should rotate that. Select this one, create partition, doing the same, 3 point, this one, and this one. Also this one, 3 point, this one, and this one. Now let's do the same. We select these edges, and also the one on the bottom. It should be the same, 8, and this one should be 3 as well. Let's mesh it and see that in the assembly, as you see, these lines are in line, and also these lines are in line. If you don't see that, it means the meshing is not correct. Okay, now let's jump back to the interaction and see whether the rigid body still exists. So yeah, as you see, because we parted this one, the reference point disappeared, so we can create the reference point here. Okay, now here we want to select the reference point here. Okay, now we want to create another interaction. We name it coupling. We select this one, click on done, and it should be node region. Let's put it on cell, and done. It's okay. Now let's go to the load, and here the load was created on reference point 2. So everything is okay. It's time to go and create the job, pin and plate. Submit, and I come back after the job is completed. Job is completed. Let's go to the results. I put it on this one. We can rotate it a little, and let's see the animation. Yeah, the failure happens here in the shear out formation. If you look at a real-time shear of a pin structure, you see that our simulation is totally in line with this one, so that makes sense. Now let's plot force versus displacement. XY data, ODB field output, and from here check RF1 and U1 from the unique nodal, and here from pick selection from the viewport, we select this one, click on done and plot. And we want to go to operate on XY data, combine U1, RF1, and plot this expression. As you see here, the force goes up and comes down because of the damage load, and here starts failure. And if you look at the paper, you see here follows the same trend. There's a damage load here and there's a failure, and it goes sharply down. But keep in mind that I haven't tried this paper's simulation and I'm not trying to validate my results with this one. It's just a random paper. And that's it. Thanks for watching. If you enjoyed this video, give a thumbs up and hit the subscribe button, and check out the video on the screen before it ends. Stay tuned.